Okay, so in this video we're going to look at resolving vectors. Let's say that I'm given 2 bits of information about the motion of this ball here. First of all, I know that it's moving at 60 degrees east to north. So I know that it's east 60 degrees to north. And I know that it's moving at 40 meters per second velocity. So I'm interested in resolving this one vector, which is diagonal, into 2 that are within either the x or the y plane. Okay, so I'm trying to break this one vector into 2 vectors. First thing we need to notice is that along the y plane here, that would be exactly the same direction and magnitude as though it were drawn here. And hopefully now you're starting to see the triangle forming. Now we know that along this vector it's 40 meters per second. You can think of that as the size of the hypotenuse. So the hypotenuse is essentially 40, and we're given the angle. So we've got our opposite, and do the other one in green because that's what I'll be using when I'm answering it. The opposite and the adjacent. So in order to find a value for this opposite, then we need to use either SO, CA or TOA, and as it's the opposite and hypotenuse that we're concerned about, we'll be using SO. So we know that sine 60 is equal, that's 60 degrees of course, is equal to our opposite, which we're trying to find. We'll just do an O over our hypotenuse, which is 40, and obviously that's going to be unknown over 40. We need to get the unknown by itself, so it's simply 40 sine 60 is equal to our opposite. Now the calculator is giving us a value for the opposite of 34.64 degrees. Sorry, it's not degrees, is it? Of course, it's meters per second. Now let's look at the significant figures. We've got 4 here, and we've only really put 2 sig figs into the equation, so we need to round this to 35 meters per second. Very similar with the green, the adjacent. This time we have the adjacent in the hypotenuse, so it's CA, which tells us that cos 60 is equal to the adjacent, which we need, over 40, which we can rearrange to 40 cos 60 is equal to A, and if we put that into our calculator, that gives us a nice round 20 meters per second. Okay, so we can say that along the horizontal component we're moving at 20 meters per second. According to the vertical component, it will be moving 35 meters per second. So that's how you split one vector into 2. Okay, so that's how you resolve one vector into the 2 planes that we concern ourselves with, the x plane and the y plane.